Thanks, Igor. Okay, first of all, quick rundown of the agenda. I'll be doing a quick introduction to myself and to the talk. Next, we'll just go through some basics of mainframes and mainframe concepts for those people who aren't familiar with them, which I guess would be quite a few people. An even larger set of that Venn diagram would be people who don't know much about COBOL, so I'll just give a quick description and discussion of that later. And then I'll move on to how you would actually go about doing a security review of COBOL, the kind of issues you can find, things that don't really count as issues but look like issues. And I'll go through a quick process you can use for reviewing things, show you what tooling is available, tooling that you can use for that, and kind of how you can write these issues up and communicate them to other people. So for anyone who doesn't know, I'm Nick. I worked at IOActive for a few years. Started off originally as a software developer, found out how much fun it was to break things and became a pen tester. And I've done various kinds of work over the years, code review, pen testing. And some of this kind of stuff dates back to the years when I was a software developer in the financial sector. A lot of the time when you do look at these systems, you'll find that although you might think COBOL isn't common, it's still common or still around in the financial sector. Mainframes, you might think of them as something a bit old and archaic, and COBOL as being equally old and archaic. There is still quite a lot of it around, and they're still in fairly wide use in banking, insurance, generally running large-scale batch processing, a lot of those sort of overnight payments where you see all your card transactions from yesterday go through overnight and they've happened in the morning. It's down to this kind of large-scale batch processing overnight. You might be surprised that a lot of this stuff is still here, but it's a non-trivial process to replace any of these systems. They in the case of somebody attempting to make a cost benefit for replacing all this stuff, you would be spending several £1 million to be in the same situation as before in some respects, which is not easy to justify. I've witnessed replacement of these systems being done in the past, but it's, several months and several £1 million. And it's not, and so there is still a lot of these systems out there still being run. Mainframes, they are, I guess, inside the head of the typical person, they are a huge big box and an old-fashioned computer, but they do have some significant differences from standard PC or server architecture. As a sort of broad description there, you can all read faster than I can talk, so I'm not going to read out every slide to you, but they have a kind of different stack system, different sort of architecture layout to the average computer, with more processors that run faster, and they were like the original home of thread exactly multi-threaded architecture, but multi-process architecture, and have traditionally been able to run these large-scale processes alongside each other. COBOL, I know you're all thinking it's like a weird thing and might seem a very unusual language. It's when you see it written down, it's actually not that drastically different. Somebody with a reasonable sort of programming background can still follow it through and read it while being disgusted at the all uppercase kind of text. And it stands for Common Business Orientated Language. It's just slightly newer than Fortran, so it's the second oldest language that's still in regular usage and still out there in the real world being used. And it was originally designed as some way that normal people could program and regular business people could understand and write programs. And there was this idea that such readable code would completely put a stop to programming errors. A bit like it shares something in common with a lot of other programming innovations. And the way it was supposed to help people, because it was developed in the 1950s when I guess programming wasn't a widely a skill that many people had. Reading something like A equals A plus 1 seems nonsensical mathematically, and for somebody with no knowledge of programming, it looks weird. And so the original syntax of COBOL was, as you see there, this add A to B giving C. The full stop is not a mistake on anyone's part. The statements always end with a full stop, not the semicolon that the same person would use. And it was written like that to make it clear. And over the years, it became obvious that people didn't actually like this long-winded way of writing it, and a more sort of standard programming notation was introduced. So if you're ever reading it, you can find both of those kind of versions of the same statement in use. It was originally written not on sort of paper sheets, because we really are getting back in time now where somebody would write it out on paper sheets that would be translated into punch cards and fed into a mainframe that probably had valves. As I said earlier, the places where you're most likely to see it is in the financial sector. It's still fairly widely used in overnight batch processing for pensions, insurance, a lot of investment banking kind of stuff, and regular batch processing and banking. If you're ever in a situation where you are reviewing it, it always has this nice description of the file at the top where you can see who wrote it and at what point in time. And it's not unusual to find code that's older than you are as you're working on it. In line with the fact that it's still in widespread use, that there is still an industry of replacing old mainframes with new mainframes, and there are some banks that have quite cool looking large-scale newer mainframes in use. certainly in terms of why you would want to do a COBOL code review, I guess a lot of you have come across people who feel something shouldn't be tested because it's never gone wrong. That's never really a guarantee that something's bound to be safe. And you will find that in a lot of these older systems, they're written around a certain set of assumptions that field lengths will never grow above a certain size. So you can come across situations where inflation might, or changing values of money can cause disaster. So there is definitely a case for doing them on that basis. And a lot of the time you might find yourself in a position of being asked to do a COBOL code review just on, because this stuff has never been tested before. There are more and more, I guess, jobs coming through where there is more pressure from above to review every single system, test every system, and that starts to spread out to systems that have just been left on their own since the 80s untested. Last benefit, best of all, it resembles Hollywood style hacking because you get coloured text on a black background. If you're having a situation where you are going to be doing a COBOL code review, this black text on a background stuff isn't the best situation. You would want those, try to get those files transferred to you ahead of time so that you can search them properly. You can use proper code review tools on them, and you can read through them more comfortably, have more than one window open. And if you are planning to learn more about this stuff, there are a lot of YouTube videos and a lot of IBM material freely available on site. You can go and learn how to use COBOL and practice in various test environments. The YouTube videos have got a bit of comedy value as well. You get to see how the original programmers looked in previous years. You'll see beards, flared trousers, and you'll also see clothing that's out of date. In terms of the structure of programming, the programs, it's very formalized because it was written back in the days when they were all written out on these paper sheets and had to be presented in a certain standard. So you'll have this identification division is always the start of the program and gives its name and who wrote it, what dates. The environment division describes what hardware it should run on and what machine it's for. And you'll have this data division, which gives you where the data is coming from, what's used in the input-output operations. And in some cases where their programs interact with each other, there's a linkage section that will describe that. And then the bulk of the program is always in this procedure division, which has a very sort of standard procedural code outlay of top to bottom with subroutines. And because of the age of this stuff, you will see a lot of go-tos in there. That is the way they were originally written out. Back then, that part you see at the top, the name of the system and program, is what would be in the identification division we've just talked about. And they were always written out with this sequence numbers, the line numbers, which page you're on, which relates fairly directly to the punch cards that had to be used in the past. Seeing that on the screen instead of on a piece of paper only looks slightly more modern, but that's what it actually looks like if you'd see it in a terminal as you're reading it or seeing it from a mainframe terminal. In terms of reviewing it, as I've said, the important thing is to get files in some format where you can read them on a laptop or your own machine, and you can view them in an IDE. Weirdly, VS Code and Notepad++ and stuff like that will display them properly with the right coloured syntax, and you can read them in a much easier way. And there are a few sort of tools out there that will scan the code and report some errors. Part of the reason that it's good to have a tool is that some of the things you'll be looking for would be mismatched field sizes on the data types, which lend themselves more to automation. But in terms of the kind of things you're looking for, it's in some ways quite different from web and mobile stuff. You're relying far more on things like trusting the user too much and not really anticipating changes. And by the first one there, I mean trusting the user too much. It would look that way to a modern person, because in the past a lot of these systems would have been used with rigid instructions by somebody who knows what to type into the terminal, and you can kind of cause disaster if that input's being communicated over a network or through a GUI. The failure to anticipate future changes is down to field sizes for a lot of data types. Is it sufficiently large to hold the amounts of money or whatever other data type it is? But most of the time it will be money. A lot of the time when you are looking at this stuff, you will be looking at something that's been in use for 20 years or 30 years, and it has worked fine. So you have to kind of know what you have to look for, partly because you have to convince somebody later that something that's worked okay for 20 years can still go wrong. And so the kind of issues you will be looking for fall into this category of, okay, it's working now, how could this go wrong? Which I'll speak about the data types in a moment, but there's a lot of programming statements that allow one piece of data to be moved to another field, typed, or allow it to be populated by user inputs. And you'll find that some of the sort of things that might be working now but could go wrong in the future are these moving mismatched variable types between fields, the classic sort of C but with different consequences issue of mixing signed and unsigned types, and mismatched field lengths, and trusting user input a little bit too much. I've talked there a bit about mismatched field types. There is a field type that has a fixed number of bytes called pick, and it allows you to specify different types. So numeric values would be, as that first statement, pick 9 for a numeric field with the length following it. and S9 for signs. It's a bit like C in some ways, in that there's a lot of trust placed, and it takes the attitude of like C, that you are telling me to do this, I'll try and do it as best I can. After all, you wouldn't have asked me to do that if it was wrong. And so it will just attempt to copy alphanumeric variable into a numeric field, just as you've instructed it to. And so in this case, you can see there's pick X, which is an alphanumeric field there for card start poll. The next variable definition down is a sign numeric variable. At some point further down, when it copies with that move operation, that code there would be copying an alphanumeric variable into a sign numeric variable. What would normally happen here if somebody puts 12A or 12B is that it would just do its best and crop out the letters and just copy numbers across. So it can kind of lead people to weird consequences. But as I said, it dates back to the days when the person who was using this terminal application would have had 2 days training in an instruction manual and been told, never ever put letters in that field there. As C programmers will know, there are some things that should never ever be mixed. And it does allow you to copy signed variable values into an unsigned destination. It will just assume you've done that on purpose, you asked for it. And like this code here, copies that hgadmax for the first variable, which is signed, into gadmax there, and that would just copy the signed variable into the unsigned fields. It's not quite as horrific as C. It will not cause any weird conversion error. It will just happily truncate and remove any plus or minus at the start. That will just vanish. The variable will then just be treated as a positive value. Again, like C, it will allow you to copy a larger variable into a shorter one. But again, like C, unlike C, it does not cause the same levels of disaster. Nothing will be overwritten. The variable being copied into the smaller field would just be truncated. So if there's any situation where this is dealing with a cache amount, and in the past, that's always been less than 4 figures. So it's been copied into a 4-figure field. Any 5 sort of figure length being copied into that 4-figure would just be truncated. That money would be lost from the calculation. And that would just be the consequence of that. In terms of accepting user input, this accept command is what's used to read the user inputs, and it will just copy that. If you've put no measures in place to check the input, that would just be copied from the user input field, as in into the accepting input field, as in the part that's highlighted red there. I will put all these slides online afterwards for anyone who wants to see this in more detail. I'm talking about trusting external data now, possibly something you might not have been expecting to crop up in this is that you can have SQL injection in COBOL. It does allow you to build up dynamic SQL statements in the program. So somebody could conceivably put the right kind of SQL into the input field and cause the SQL injection to take place. The principal defense or reason it might not happen so often is usually the size of the input fields in the terminal. If you've ever had the joy of using an AS400 terminal or IBM mainframe terminal, you'll find a lot of the time it's the money amount you're entering is a certain fixed size, and you can't. You'd be limited in your SQL injection attempts to something that would fit into the field size. And you would experience this typical thing that happens to anyone who's privesced an AS400 or IBM mainframe, of finding the amount of money you can steal is limited by the field size. The COBOL's SQL injection example here, you can see that eerily familiar to anyone who's ever looked at PHP, has got this transcust ID variable being placed in the middle of a dynamically built SQL string. And so anything placed in there could cause issues. Moving on from things you didn't expect to see in COBOL to other things you didn't expect to see in COBOL. You might not have expected buffer overflows to be another thing on the list, but again, it's something that's not quite as disastrous as it sounds. It's more the system architecture that's the protection here. The whole stacks are implemented completely differently from the virtual address space that you'd be used to seeing. So variables are held in a separate area from the address pointers and that kind of thing. And there are also safeguards within most of these systems against the overwrites. If you do see any of those mismatched variable size issues we saw earlier, they would normally be truncated. You can put an on overflow statement in there which would warn you that the truncation has occurred. That there would be nothing as nothing quite as disastrous as a C overflow where it overwrites the next piece of data. It would just be a loss of part of your data that's been input. It has this whole kind of separate thing where as I say, that there's an address stack and a memory stack, and the two sort of the variables are managed in a completely separate area from any instruction pointers. In terms of other functions you can look for while you're doing this, there's self-modifying code is also something you can do. There's you will invariably find a lot of go-tos when you're reviewing this code. They were written in the times when that kind of behavior was viewed as normal. And for a statement like this, alter proc1, proceed to proc2, as it says there, it will completely alter the behavior later on at compile time. And so when it encounters a go-to proc1 statement, it will treat that as a go-to proc2 while it's running. There's although you will be looking at old code, if you're ever looking at new code, I guess there's always the chance of telling people not to use go-tos. You will find go-tos, it's got the same kind of hazards that it has in any other language of creating unreadable spaghetti code. It would be a brave man who tried to fix any, or person or lady, who tries to fix any of this stuff and rewrite it, but they work in conjunction, go-to and entry points. Something you can check and actually come up with recommendations for more frequently is the whole safe file management thing of where it's reading the data from, what degree of validation takes place, what protections you have around what you're reading. Going back to that earlier code I showed you, the display and open verbs are the two that are used to read all this file data and bring in external data into the code. A lot of those sort of mismatched file types and, mismatched variable types are the sort of thing that lend themselves much more to automated scanning. You can, to some extent, you can, if you have the resources or somebody else is prepared to pay, there are tools like Veracode and Checkmarks that will check for those mismatches. VCG modesty doesn't prevent me from saying I did write a tool that can check that for you. I'll give you a quick look at that in a moment. It's downloadable from there. But yes, I did attempt to write something that would do all that whole thing for you of reconciling the different data types, and it looks like this when you run it. It will attempt to reconcile all the mismatched sort of different size variable types or different sign variable types. I realise this is a bit of an underwhelming video after that long wait. But it will allow you to quickly find and confirm that something has been found in the code. And so it will give you this sort of fairly typical output like this, where you can find any sign mismatches or length mismatches and any other weird stuff like not so random attempts at random values. If you've gone through that whole process, then you might be left with quite a lot of findings at the end of that, and it comes down to the whole issue of how do you communicate it to other people, and how do you report this stuff? And there will nearly always be a few things that you can communicate or convey to others. There's certain maintenance and good practice issues, as I was saying at the start in that identification division. That should always be clearly labelled. Program ID should always match the file name, just out of general helpfulness and people being able to use this stuff properly. It's not unusual to be in a situation where you find there's only one person who knows how to maintain the application, so or 2 or 3 people who can maintain it and run it, and there's always some weight on you to sort of remind people of keeping it maintainable, and ideally in a situation where it could be handed over to the next person. And in terms of actual defense and stopping anyone unauthorized from looking at the vulnerabilities, there is an actual file marker you can use to place them in this execute only library and stop just anyone from looking at the codes. It can be a bit difficult to kind of communicate to people sometimes that an application that's been running fine for 30 years, you are going to them with a list of 30 things that are wrong and a to-do list for the developer. In terms of contextualizing it for yourself and for them, you can always use this, how much do you expect this monetary amount to rise? What effect will inflation have? In terms of copying a large field into a smaller field, and do try and emphasize to people it's the current situation is not future proof. At some point in the future, that amount of money can get too big, and it may reach a state where the amount is too large, it might start overwriting. It's always been written in the past by developers who are expecting it to never get larger than a certain amount. But I guess there's these situations where mortgages are certainly a thing where they've probably gone to the levels of what would have seemed fantasy to someone 40 years ago. And certainly, again, in terms of that whole trusting file management and trusting user inputs, it's more, again, another defense is that just because nobody's put that wrong value in yet, it doesn't mean nobody will. As I said, in the past, the traditional defense for a mainframe was a locked door and a key card, and access was traditionally controlled by only having a few terminals to access it. And part of the traditional defense has been not having something to practice on. That's been, I guess, more of a defense against the things being hacked rather than any actual robust coding or robust defenses. And so just to summarize, it's, I hope I've emphasized it, it is weird, but it's probably not as weird or obscure as you might have thought. And no matter how long it's been running in a safe or seemingly innocuous way, that is no guarantee that nothing will go wrong in the future. And there can be things like SQL injection lurking in there, really serious issues that haven't been found, which I feel is, as I said, partly down to a lack of a practice environment being available to people, which does lead to this lack of the same sort of skill levels and understanding that you might get against other platforms.